Growth in bacteria is defined as an increase in the number of bacterial cells within a population. Growth trends within a bacterial population can be illustrated using a bacterial growth curve, such as this one. Growth occurs in 4 phases: lag, log, stationary, and death. Let's look at each phase of the curve to see what's happening. When dormant bacteria are transferred to a fresh medium with plenty of nutrients, they spend some time switching their metabolic machinery from the dormant state to an actively growing state. During the lag phase, the number of new bacterial cells is equivalent to the number of dying cells, resulting in a horizontal plot on the growth curve. The lag phase can last from less than an hour to days, depending on the species of bacteria. During the log phase or exponential growth phase, the bacteria are actively undergoing binary fission. During the log phase, the bacteria double their numbers every generation period. The generation period can range from 20 minutes to days, depending on the species. As long as there are plenty of nutrients and little waste buildup, the bacteria will continue to grow exponentially. It's convenient to represent the growth of the bacteria on a logarithmic graph because the numbers of bacteria increase very rapidly with each subsequent generation. When the log of the number of cells is plotted versus the generation, the graph is linear. After the bacteria have grown for a while and they're starting to deplete the nutrients in the growth medium, some of the cells begin to die. The stationary phase is reached when the number of new cells equals the number of cells that are dying. After the bacteria have depleted most of their nutrients and their waste buildup is getting too great, the bacteria begin to die in larger numbers than are made. If the death phase is carried on for a long time, most of the cells will die. If a cell is to survive, it must switch its metabolism back to a dormant state because there are not enough nutrients available for any more growth.